Hey everyone, welcome to the third installment of my weekend project. If you all recall from the last 2 weeks, I'm working on a motorized TV mount, a TV antenna mount. And if you saw the episode from last week, you'll remember that I ran into a snag. What happened is when I tried to move the stepper motors that I purchased with the driver that I also purchased, what happened was the stepper motor wasn't moving at a specific amount of increments. What I was trying to do is to have the stepper motor move in 90-degree increments, and what happened was it turned out that it wasn't doing that. So I decided this weekend what I'm going to do is I'm actually going to look into why that is, and to be honest with you, I actually figured out what it is already. And so in this episode, what I'm going to do is I'm actually going to go through what exactly is the reason why it's not doing that. And going through this also helps those individuals that are planning on becoming engineers understand that the engineering process is not just something that you can do real quick. Okay, this is not magic that we do. Engineering takes a lot of work, and so you're going to see me go through the process of understanding what happened and then troubleshooting the issue. Now, in troubleshooting the issue, what that means is I'm going to have to go through the data sheets for some of the parts that are in the circuit, and you'll see how I'll analyze my way through it and understand exactly what the problem is. And so stick around for this episode. We'll be right back after this message, and we'll start going through the analysis and understand exactly what is the problem and how we can rectify it. All right, so here's our circuit as it was set up last week. And so you can see that the driver is down there. Our Arduino board is up here at the top. We have our stepper motor over here. And then we have two sources, power sources. We have the power supply over here, which I believe was set up to be 10 volts at, let's see, 1 amp last week. And so I went ahead and set it up that way for today. And so on here you can see that I'm connected to the power supply there, or to my USB port to drive the or to power the Arduino. And so what we're going to do again here is we're just going to go ahead and make sure everything still works as it did last week. So I'm going to go ahead and turn on the circuit by moving this over here. And it looks like my Arduino stopped, so let's go ahead and reset it. Alright, so there we go. And okay, so actually you're seeing part of the issue here. It started going for a little bit and then it stopped. Let's hit reset again, maybe it'll start going again. And oh, there it goes. And you can hear the clicking of the power supply in the background. Okay. So as you can also see, the power supply, or pardon me, the stepper motor is supposed to be making quarter turns or 90-degree turns. So it should make a total of 4. And actually it's a little bit off. I'll twist it up here so you can see. Oh. And as you can see, it's a little bit off. And so that's what I have to correct. And like I said, I figured out what the issue is, and I'll go ahead and tell you all about it. So let's go ahead and take a look at the data sheet for the driver that's driving the stepper motor, and we're going to look under the features section in particular here, And so one of the first things you'll notice here, or the first thing that's on there on the features, is that the output, the current output per driver from the driver circuit is only 1 amp. All right. Second thing, in terms of supply voltage, 4.5 to 10 volts. And then that there's also a thermal shutdown. Now all these are going to play into what the actual issue is as we move forward. According to Texas Instrument, the recommended operating conditions for the driver would be for us to provide a minimum of 4.5 volts to the output supply voltage. That would be pin VCC2. Or go as high as 36 volts. Now the interesting thing is, if we look at the absolute maximum rating, what happens is they say that the absolute maximum ratings that we can get out of the chip, being the driver, the maximum rating would be between -3 volts and +3 volts. They have VCC2 there, but I highly doubt what they mean is VCC2 plus whatever, plus the 3 volts is what you're going to get as your max, because there's no way you're going to get more out of the chip than what you put into it. So we're going to go ahead with the max is +3 volts. So given this information now, if we look at our stepper motor, and the stepper motor is made by one-tie stepper motor, WANTAI stepper motor. It's a model 42, B as in boy, YGH, M as in Mary, 809. According to them, when they tested their stepper motor with a 3-volt input, and remember, Texas Instruments said that their max voltage out is 3 volts. When they checked their stepper motor at the 3.06 volts, they got that it drew approximately 1.7 amps of current per phase, and they found that the resistance within the coils was approximately 1.8 ohms per phase. Okay, so using Ohm's law to verify the numbers from the stepper motor data sheet, we know that V divided by I gives us R, and so if we take the 3.06 volts divided by the 1.7 amps, we end up with 1.8 ohms. Now, under our conditions, the conditions under which we put the stepper motor, let's just go ahead and assume that we're getting a 3-volt maximum out of the driver. So if we get 3 volts maximum out of the driver and we divide it by that same 1.8 ohms for each phase, we end up with 1.67 amps. Now the thing is that 1.67 amps is the amount of current that's going to be drawn by the stepper motor. And that 1.67 amps is more than the 1.0 amps which the driver is capable of delivering. So because that is the case, what ends up happening is that enough current isn't being sent to the motor in order to spin it. So that's the reason why we're having some of the issues. There isn't enough current being sent to the motor in order to make it turn that entire 90 degrees. So what if we, let's say, try to do something a little different? Let's see if maybe if we reduce the voltage, if we can actually make this happen. So what I'm going to do in the next segment here is I'm going to reduce the 10-volt supply source down to 4.5, and we'll see what ends up happening when we do that. All right, so I went ahead and set the power supply to have a minimum of 4.5 volts, which is the minimum operating voltage for the driver. I also made the current 2.2 amps, and so that should be within the operating range here for the driver, so that we can check to see what it's doing with the stepper motor. So let's go ahead now and look at our stepper motor again, and I'm going to go ahead and connect or start the stepper motor. And as you can see, let's turn this a little bit. So that's 1, 2, 3, 4, 5, 6. It's a little bit more than 5 in order to, let's try that again. 1, 2, 3, 4. Yeah, you can see that it's not making the full 90-degree turn. And if you look also at the power supply, you'll see that it's, of course, the current is changing there as it turns, and the current limiting light isn't on. So what's happening here is at least from what I'm gathering, the driver or the motor is asking for more, and we just cannot supply that given the driver that we've got. Remember, I set the power supply to limit at 2.2, and it never even gets there. Okay, so the driver isn't capable of delivering that amount of current to the motor, and so that's why we're having the problem turning it the full 90 degrees. It starts off okay, and then by the end of each turn or each quarter turn, it actually doesn't make it because the current is too low at that point. So we're gonna have to actually order a different driver in order to drive. Let me go ahead and turn the power supply off. We're gonna have to order a different driver, or I'm gonna have to order a different driver for the system here in order to make this work. Alright, so until those parts come in, I guess we're in a little bit of a holding pattern. So stay tuned. I'll let you know as soon as there's additional progress being made.